All right. Well, this week won't take too terribly long. It is the topic I was talking about last week. We were talking about memory, and I had mentioned that there was this idea called virtual memory. So, virtual memory, the idea of virtual memory is that sometimes you just need more than what your system is capable of providing. So, if your system has 4 gigs of memory, and you need 4.5 gigs allocated, or more than 4 gigs. You're in this situation now where the system itself will need to figure something out. And what ends up happening is old memory. Memory of applications that you haven't used in a while. So say that the first thing you did when you opened up your computer was open up Microsoft Word, and then you closed it. Well, that stuff doesn't leave memory until there's a need for it to go away. So let's say at that point you were only using 3 gigs of RAM. Well, you decided to fire up Chrome and then open up about 100 tabs, and now you're in need of more memory. So the last thing, or the thing that you have done the longest ago, is what gets dumped out of memory to make room. Now, it doesn't dump it straight out of memory. It puts it in kind of like a holding area, and that is virtual memory. So virtual memory is really just an area on your disk where old memory is stored when it's no longer needed. But again, your operating system doesn't want to just drop it all because it's still useful. You were doing this thing. You may do this thing again. So having it in that holding area will speed up access times by a little bit. Now, if you're on a spinning disk, virtual memory is going to be slow. It is still slightly faster than reading it off of the disk by itself, because a lot of times reading it off the disk, you may have to go to multiple different spots on the disk. So when you install software, it gets put wherever Windows decides to put it. In NTFS, the file system that Windows uses, it can very well just throw it anywhere where there's empty space. And if you go and try to run that application, the hard disk has to seek over here, seek a little bit over here, a little bit in the middle, a little bit on the end, whatever, and then gather all that up and send it to the CPU or the operating system in general. If it's in virtual memory, all of that stuff is already collected in one spot. So again, it'll be slightly faster, just it's not going to be night and day or anything like that. Now with SSDs, this issue is not much of an issue anymore, since no matter where it is on the disk, the SSD can access it at the same in the same amount of time. So virtual memory is less required than it's been in the past. But just know that the idea is there, and it's all collected in one spot, held in one spot until you need it again. And that's pretty much the idea. So, virtual memory, RAM overflow. That's a simple way to think about it. You still want to keep it together, but it doesn't fit in RAM anymore, so we're going to stick it here. Now, cache, it's kind of in the same vein, but instead of it being stored when you're not using it, cache is actually what is needed right this second. So RAM is located in the middle, where this application was recently started, so I have it in RAM, and if you need it again, it'll be really fast because I can do 21 gigabytes per second transfer, right? Like, RAM is fast. Cache is even faster. We're talking in the hundreds of gigs per second, if not faster than that. It's been a while since I've actually gone and looked at how fast L1 actually transfers. But the idea is that this memory lives on the CPU itself. So you get to decide how much RAM you have, right? You can buy more, you can buy less, whatever. But cache is literally connected to your CPU. It's part of the CPU. It was a consideration that Intel or AMD or whoever had for your particular CPU. And they settled on whatever that value might be. A lot of times it's 512 kilobytes of L1 cache, and then a couple of megabytes of L2 cache, and then a handful of megabytes, like 16, 32, megs of L3 cache. And they go in order. L1 being your fastest, L2 being slightly slower, and L3 being slower than that. However, all three of these are much faster than RAM, right? So RAM is in the middle. Virtual memory is the slowest of it all and resides on your hard disk or your SSD. And L1 through 3 cache is the fastest memory you can get your hands on. But you don't get to decide how much you get. That is decided by the processor that you buy. The faster, more hungry processors will have more cache. And typically, cache is a multiple of however many cores you have. So if you have a 2-core processor, you'll have an amount of cache per core. A lot of times it's 128K per core. So that means you have 256K per processor. So a whole entire CPU. If you had quad core, it's multiplied by 4 instead. 8 multiplied by 8. 16 multiplied by 16. That's the idea. Now, if we look, you can actually see what's going on. So if I check out the system, I can see I've got a Core i5-4590. Intel Arc's website, arc.intel.com, tells you somewhere around here where the cache is. Maybe I missed it. Oh, here it is. 6 megs of cache. Right? Memory located on the processor. So it's probably something like 1 megabyte per L3 and the other 2 megs divvied out between level 2 and level 1. So that's the idea. Whatever the CPU is actually working on in that moment is in cache. Everything else is in RAM. And what can't fit in RAM, we move to virtual memory. That's how that goes. Different sets of memory for different things. Now, the only thing we can deal with in software is virtual memory. So the cache is decided by your CPU. The RAM is decided by how much money you got and how much you installed into your actual motherboard. Virtual memory, though, can be tinkered with. Windows typically deals with it for you, so you don't really mess with this most of the time. However, if you have an idea that you're going to be doing CAD things and you have 32 gigs of RAM, but you know that most of these drawings end up being like 100 gigs, require 100 gigs of memory per drawing or something like that, then you probably want to go and then just set up your Windows virtual memory to have 64 gigs of memory, or of virtual memory, ready to go. Matter of fact, you might as well have an entire caching drive. So here's the deal. Virtual memory management can be done where you go out and buy a 64 gig SSD or 128 gig SSD and use the entire thing for virtual memory. That is a thing that can be done. And this is why you would go into a situation like this. Most of the time, you just don't mess with it. But if you know, or if you want an entire caching drive, you have to do that manually. So here's where you would come in and do that. So to get to this, it is not easy. You have to go through the control panel. Unless you've already been there before, hit the control panel. This is the old non-Windows 10 look. So this is why it's so hard to get to it. There probably is, but in 1909, the version of Windows that I'm running on now, it was impossible for me to find it in the typical go through the system settings kind of way. So, luckily for me, the control panel still exists. So, open up control panel, system and security, system, advanced system settings. Yes, it is a slog to get here. Under performance, settings, under advanced, tab, virtual memories here, change it. Here now is the screenshot that I've got right here. So, yep, that was a slog to get there. There's no better way to get there that I know of at this moment. So, if you can find a better way to get there, please let me know. I will write that up and share that with everybody. But As far as I know, this is pretty much it. So you got to slog through that. Now, this is checked by default in every single version of Windows. Automatically manage it for me, right? If you want to manage it yourself, you uncheck the box, the options become available to you. You can tell Windows to not set up a paging file at all. If you've got 128 gigs of memory, all right, cool, go for it. Otherwise, you probably want to at least let Windows manage it. But if you know you're dealing with massive sets of memory, you'll want to set yourself a custom size. Now, I don't need you guys to be extremely, accurate on this. There's a conversation to be had about the difference between gigabytes and gigabytes. Yeah, that's really a thing. Blame Western Digital and Seagate and everybody else for kind of distorting what a megabyte actually is. But that's the idea, right? So, megabyte. You can just, if I say 64 gigs, 64,000 megabytes is enough, right? This value is in megabytes. A gig is 1,000 megabytes. So if I tell you 64 gigs, that's 64,000 megabytes, right? So 64,000. Now, what I was talking about is that is gigabytes. If you wanted the gigabyte, the scientific notation, because bytes are 1,024, not just 1,000, right? You would need to do 64 times 1024 instead of 1,000 to get 65,536. So if you wanted to be fully accurate, that can be there. I do not require you to be that accurate. 64,000 is good enough. I need to know that you can get here and put values in here, right? So if you can put values in here, and then I tell you to go put 1, 2, 3, 4, 5, 6, 7 in that box, I can assume that you'll be capable of doing that. So I'm more concerned with you getting here and doing this than I am anything else. All right, so if we want to be super accurate again, 129,792, right? So I have 64 gigs and 128 gigs in here respectively. So the system is going to allocate 64 gigs right at boot. 64 gigs of your hard drive is already going to be used right at boot. And that can go up to 128 gigs. So I'm working with massive data sets if I'm talking about values this large. Most of the time, the initial size will be approximately how much RAM you have, right? That's there so that when RAM is full, and you have 32 gigs of RAM, right? And so your initial size here will be 32 gigs-ish. Then RAM can be fully dumped into virtual memory, and then a whole new working set can be added to memory, right? And then you'll have both sets. Now, you typically don't have to think that hard about any of this, right? If you know you need this much virtual memory, you come in here and set the number, and that's really all you got to think about it. I'm digging a little deeper into this so you know what it is and why you're setting it, right? Any monkey can be paid to put numbers in a box. You knowing what those numbers mean makes you more valuable than someone that can punch numbers, right? That's the idea here. Anyhow, the thing with virtual memory, though, is it doesn't actually set until you press the button set. And then even then, it doesn't set there. You have to reboot. So, for your lab, do not press that button. Especially if you are doing this in your actual computer, on your actual laptop. Those of you running on Macs, you get to do it in the VM. Those of you running with Windows on your laptop, you can get the screenshots from your laptop itself, but if you click set, you're gonna have to go in there and unset it if those settings affect you adversely, right? Anyhow, that's how you'll go in and set that. Does that make sense? What virtual memory is, anyway? Setting it is a matter of being able to go in there and click that button. All right. So Windows breaks out their virtual memory in 3 different spots. The first spot will be pagefile.sys. This used to be the only place that you could find virtual memory. Since Windows Vista, this idea, so pagefile.sys, that's where all virtual memory used to live. Since Windows Vista, Windows 7, the idea of hibernation exists. This is another reason why you want at least the amount of memory in virtual memory, right? So if you have 32 gigs of memory, physical memory, you want 32 gigs of virtual memory as well, at least. So hibernation is the idea that you should be able to close your laptop, and if for some reason you're going to leave it for a week, Suspend wouldn't be able to handle that. Suspend on a laptop still continues to keep RAM powered. That's like 3 watts, 4 watts, right? But your 40 watt hour battery is not going to be able to power that for a prolonged amount of time. It might last 3 or 4 days, but after that, you're out of juice. You will run out. So hibernation is the idea that we take that one step further. We take everything in RAM and write it to the disk in virtual memory. And then we can power down RAM as well, leaving your battery untouched. It's the same as if it were to be turned off, your laptop, power-wise. So you turn it back on, everything from the disk and virtual memory gets written back to RAM, and your system resumes as it was prior to this, prior to actually hibernating it in the first place. So Hyberfill.sys, though, is a totally separate section of RAM, or virtual memory. It's a totally separate file, and will expand to however big it needs to be. This is the newest. Since Windows 8, we've had this App Store in Microsoft, in Windows, where you can go to the Windows Store down here, and then you can install, whatever, Windows Subsystem for Linux, or Frozen 2, yay, whatever that is. So if any application launched through the Windows Store requires any virtual memory whatsoever, it goes here instead. These are for your 32-bit, 64-bit Windows-specific applications, executables that you installed. This is for applications that you installed through the Windows Store, and this is for hibernation only. These 3 things make up virtual memory at large. That's it. Add all that together and you figure out how much virtual memory you're using on a Windows system. And you can go in if you want. I don't have WinterStat. You can't look at these files by themselves. They are hidden from you even if, I believe, even if you're showing hidden items. It still doesn't show you. Right? Program data, sysreset, those are hidden items. But for some reason, they're still hidden. You need an application like WinterStat. So WinterStat is actually pretty useful for if you want to figure out where all your files, where all your storage is going. Windows has got a pretty good idea, or shows you a pretty good way to figure all that out. But WinterStat actually shows you on a per file basis. All right, so I'm just going to install this real quick and run it in the background while we go. I'm going to just choose the C drive, hit OK, and we'll come back to that. All right. So let's talk about Linux. So Linux is a little different. Linux, in the past, has used only partitions, like actual partitions, to store swap. Now that's a different word that you haven't necessarily heard yet. Windows calls it virtual memory. Linux and Mac call it swap. The idea is the same. Memory that is in RAM but needs to be moved to the disk, that job is called swapping. So swapping memory out of RAM into virtual memory, into the swap space. That's the idea. So swap space is pretty important. More so to Linux than Windows. But in modern Linux systems, specifically those of the Debian persuasion. So that would include Linux Mint, that would include Ubuntu, that would include a lot of the most popular distributions. So a lot of the distributions that you're going to be familiar with already do this. So the newer versions of Linux tend to create a swap file, same as Windows, right? This file in Windows. Linux creates one similar to it. And, of course, that file is written to as needed. But older systems and Red Hat-based systems, so ones that you find in the enterprise, more often have a partition for swap instead of a file. So on your disk, you literally carve out a section of that disk space just to use swap. And the more memory you have, the more likely it is that you're using entire disks for swap space. This is why Linux was much slower to move to a swap file than Windows was, just simply because Linux is used on servers more often, and servers tend to have lots and lots of memory. Disks, for the most part, were stuck in time for about a whole 5 to 10 years at about 75 gigs and 120 gigs, respectively. So if you had 64 gigs of RAM and a 75 gig disk, there's a good chance you just dedicated that entire disk to swap space. So anyhow, that's why this is the way that it is. Swap space just happened to move slower because you find it on the server more often. All right. So I want to show this to you as I kind of go through it. But I think we're going to kind of be in a situation where I'm going to need to do two. Well, here, let me just go through this, and then I'll show you how to set it up. So because swap space was typically done in a partition, in an actual partition, on a disk, you really did not want to be changing that after the fact, especially if the swap partition was on the same disk as everything else. So if you only had one disk and part of that disk was used up for swap, you do not want to be changing how big swap is, whether that's make it bigger or make it smaller, whatever. You don't want to be changing that. The recommendation is, if you have 16 gigs of RAM and your swap space is 16 gigs, therefore, being just enough, you do not want to make that bigger if you decide to upgrade one day to 32 gigs of RAM. Right? Swap is now too small for the amount of RAM that you have. You want to make that swap space 32 gigs. Well, the recommendation is blow everything away and start over. That way, you have the right amount of swap, and the reason you don't want to resize partitions is that if you resize partitions on top of where data already exists, that data is now gone. So think of it like this. Right? So say this was my swap space, and my C drive is full. I'm going to shrink my C drive out to here, save me about 50 gigs, and then I'm going to take this and then stretch it into it. So the new marker, partition marker, will be here. So this will have extended to the left, and this will have shrunk to the left. Now, if there were data written on the end of this partition, that data's gone. We have overwritten it. This is why you don't want to extend swap overall. So avoid changing swap space. Now, there are better tools to help you deal with this, and that is the Logical Volume Manager. We're going to get into that in the Linux course. I won't torture you with it in this course. But the idea is LVM gives us a way to actually restructure how partitions are written. They're not actually partitions at all. They're just virtual segmentations that we put there ourselves. So this will help you defeat that rule. Never change the swap partition size. LVM will help you defeat that. But like I said, modern systems just use the file style anyway. So there won't be any partition resizing in most modern systems anyway. So anyway, if you just want to see if you have swap, And how big it is, where it is, the command swap on -s will tell you. So that's the status of swap. That little S stands for status. If you want to see how much is being used from a memory standpoint, free-m. So that will give you all of the memory. You want to throw H in there, would be a good idea to help you kind of make sense of those numbers. It'll throw the megabytes, gigabytes in there, make it easier to read. If you're using LVM, LV display will show you any swap partitions that you may have configured. But again, we don't do this, not during install or anything, so you probably won't encounter that. You can resize in LVM with commands, or you can use a GUI. There's a GUI called system config LVM, and then you just launch it from the terminal as root by running it by name. If for some reason you forgot to create a swap partition, but yet you still want that swap file idea, the swap space application will help you deal with that. And then you just configure it. You tell it where you want to put it, how big you want it to be, all that. Then you reboot, and then the file exists. That's pretty much it. So as far as Mac goes, can't really touch it. But if you want to mess with it, you can type this in and see how your computer would perform if you didn't have enough memory. So this is more of the test. And Control-C, by the way, if you decide to run this, Control-C will stop this. Because it will literally fill up your RAM with garbage, and then it will fill up your virtual memory with garbage, or your swap space with garbage, and then it'll just keep flowing stuff into memory, and then having it flow out to virtual memory, or swap as well. So if you just want to see how your machine will perform under really bad memory situations, you can test it this way. Control-C will stop it. All right. So what I'm having y'all do in lab is in Windows, go into the virtual memory configuration utility there that I showed you earlier, and then put those values in there. I'm literally giving you the numbers, so you can't make a mistake on these. And then in Linux, we're going to configure it old style. So I want you to set up a swap partition that, let me see, how big do I say? Yeah, you're going to need a 30 gig disk or larger, because we're using 16 gigs for swap, and then you're going to need at least 12 gigs to actually install Mint. So bigger than 30 is better. Now, this is a situation where we're not going to use this VM again. So when you build this, you can use as much space as you want to, because know that at the end of this lab, you can probably get rid of this VM without any strings attached. So you can just delete it. So if you're running low on space, don't worry too much. We'll free this back up here in just a minute, or after you're done with the lab. All right. So a new Linux Mint VM. Start it up. Pop the disk in. Start the thing. Get into it. Now I've got some instruction for you, how to go, what to look for, what to type, or what to press. But a lot of that doesn't really make sense until I show you what's going on. So give that just a minute to start up, and then we'll go from there. Almost there. Okay, so in this situation, you're going to want to start installing. And here, before I do that, And y'all may want to do this as well, because there's really not a whole lot of space in these VMs. If you've got the screen real estate to deal with this, turn it up a little bit. 1200 by 800 tends to, well, this one actually, but this one tends to be typical low quality laptop screen size. All right, so come over here, install Linux Mint. And go through the motions until you hit how do you want to install. Through those motions. I think I clicked that right. Yeah. Install or not, it doesn't matter. This is a disposable system. So here, something else. All right. So we're at a situation where we have only one disk. I mean, this is to be expected. You do only have one disk. And you're going to want a new partition table. The easiest way to deal with this is when you create that new partition table, you get one big old partition that you can deal with. The plus and the minus will add and delete partitions. So what I usually do in a situation where I know how much swap I need, I go ahead and create that swap partition first. So in this case, if you come down here to use as, you can choose swap. It doesn't need to be mounted anywhere, so it takes away that mount location. And then you come up here and decide, I want 8096, however much you need. Type in exactly how much you need. Now, historically, swap has always been recommended to be put at the back of the hard disk. So you'll want to come down here and choose end of this space. It does not matter. If you leave it at the beginning or you put it at the end, it doesn't matter. It's not a big deal. The hard disk has to work just as hard, whether it's at the front or at the end. But typically, historically, it's always gone at the end. So, if you want to be historically accurate, click end before you click OK. And then, here. The rest of your free space has now been shrunk down. Create a new partition. We'll leave it primary. We'll just keep it all primary. These are the different, so I was talking about LVM. And then there's this idea of logical partition. So just go primary here. We'll talk about partitioning a little bit later as we talk more about disks. So beginning of the space, so starting at the beginning of the disk, moving up to swap. That number is the maximum number, what it puts in there for you automatically. So you can just leave it alone, and that'll be the rest of the space. Now, ext4 is default for Linux. You can leave that alone. The one thing that you do have to pay attention to, however, is mount point. Where do you want this partition to be mounted? Now, the idea of mounting is basically where you're putting something in the system. You can mount it as any of these or anything that you want. You're not restricted to just these. But if you only have one partition, and that one partition is going to contain everything, you choose this /. Just like in Windows, where C drive contains everything, this is the character that signifies the top of the Linux file system. So everything lives in this /. So we'll get into that more and more as we talk about the Linux file system and everything else, but just know that here, this is where you want it. That is where the entire file system is going to go. Everything comes underneath this one. All right. So now we've got the main file system and 8 gigs of swap. Now, your lab doesn't have you doing 8 gigs of swap, so make sure you're putting in the right number when you go through it. And that's it. The only partition you actually have to install Linux is this one. So we could have done just plus, click OK, or choose the / as the mount point and click OK, and it'd been fine. Mint would have done the whole create a swap file thing. But because we want the swap partition, we created one. After that, hit install now. And then everything else happens exactly the way that you would expect it to happen. Nothing is different at this point. So, let it install, go through the motions, type in your name, etc., 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 and then reboot, and you're going to want to choose or type in lsblk. So, after it reboots, open up a terminal, type in that command. That is going to show you the output of your file system. It's going to show you dev SDA, that hard disk that you have, and then underneath that, it's going to show you two partitions, SDA 1 and SDA 2. You will have created both of those. So you're just checking your work. That's all this is. Take a screenshot of that output. And then, this is a bit of a trick question. I covered it a little bit when we were talking about the difference between what Windows calls it and what Mac calls it and what Linux calls it. So, go into that question knowing that it's a bit of a tricky one. I'll take almost anything as long as you're in the ballpark. But it is a bit of a trick question. Other than that, that's it. There's only two screenshots that you need. Virtual memory screenshot, LSBLK screenshot. I can gather everything I need to make sure that you did your job from those two. But these questions, right? So just answer the questions on the PDF or in the document and then export them all as PDF. I've been getting a lot of docx's and it makes grading really slow. So PDF, please. All right. Y'all good? Okay. I'll take that as I don't have any questions yet, but I will probably have 100 in about 5 minutes. All right, y'all. I'll stop it here.